So this is just continuing on from yesterday. Yesterday we saw in 9a that we have the distribution Sn, and that arises from taking n observations and adding them together. What we're doing now is we're adding those observations together and then dividing it by how many samples there are. So we've got two formulas here that we'll appeal to. Basically, we're just saying the mean, the observed mean. Okay, so we have an observed mean and then we have the actual mean. So let's talk about what we might mean by that. The observed result, like if I'm to measure the height of all you guys and say the average height of you guys is 176 centimeters or something like that. And so that would be my observed result, and that can be indicative of the true result, but it won't necessarily be the true result, okay? So if we know that the mean of the population is, let's say for the mean height of adult males is 178 centimeters, if we know the mean is that, that will always trump the observed value, okay? So if we know the mean of the population, that takes precedence over the observed mean. If we don't know the mean of the population, then we assume that the observed mean is indicative of the population mean. That's all we're doing today. So what we have in our first example is we have bags of peanuts. So we got bags of peanuts are known to be normally distributed with a weight of 765 grams, okay? So we know the mean population, the mean of the population of peanuts is 765 grams with a standard deviation of 8 grams. Now we're going to select 6 bags of peanuts at random and weigh them. So we've got 6 bags here and this is the weight of the 6 bags. Okay, part A says find the observed value of x6. Okay, so what this means is the mean from those 6 observations. And so all we're doing is adding all of those together, x1 plus x2, sample 1 plus 2 plus 3, all the way up to sample 6, divided by 6, because there's 6 there. So you're just finding the mean of this data set. So I'll just do that quickly in my head. All right, so that's the observed value of x6. All right, however, on to the next part A, I should say part B. Find the mean and standard deviation of x6. So we're going to use this description up here. That if we know the mean of x, all right, the mean of the population, then it will always trump the observed result. This is our observed result. However, we know the mean of the population. And the mean result of the population is 765. We're told they're normally distributed and the mean is 765. So we're told find the mean and standard deviation of x6. So the mean of x6 then is 765. So just to reiterate, if we're not told this value, and occasionally we won't be given a population mean, then we assume this one is indicative of the mean of x6. However, if we are given it, this will always trump the observed value. Okay, on to the standard deviation. So the standard deviation of x6 then will always be according to this formula. It's the standard deviation of x divided by the square root of n. And in our circumstance, the standard deviation is 8. And the number of bags of peanuts is 6. That would be the standard deviation. Okay, so that's what we're doing in this exercise, is we're trying to draw out the difference between the observed mean and the mean of the population, and that's going to lead us up to 9c in the central limit theorem. So yeah, that's our plan for today. Any questions about those two? All right, let's get into that exercise, and yeah, off we go.